we're going to take an improper integral here. So we're going to take a definite integral, but infinity is going to be involved as one of our limits. So here's the improper integral. So why is this an improper integral? Yeah, it has infinity as the upper limit. What I'm going to do first is figure out a way to evaluate this integrand, or take the antiderivative of this integrand. I'm not going to be able to use substitution here. If I tried substitution and let u equal the denominator, then I'm going to get du is equal to 2x plus 4 dx, and I don't have that in the top. I don't have any x's in there. So what am I going to have to do? Partial fraction decomposition. I'm not going to expect you to write this down, but what we do here, if you guys remember partial fraction decomposition, we're going to split it up into two fractions with the two factors from the denominator here as separate denominators in our two fractions. So this is going to take up quite a bit of space. I did the work ahead of time so that we could go through it pretty quickly, and we end up getting b equals 1 and a equals -1, so that integrand can be rewritten like that. So the first thing I do here is I rewrite the integrand using the partial fraction decomposition. Everybody okay with that? Once I do that, then I'm going to rewrite it, and I'm going to rewrite it as a proper integral. So what do I do with this infinity here? I'm going to change it to a variable, and I'm going to allow that variable to approach infinity. So I chose t here. You could choose any variable you want, but I'm going to take the limit as t approaches infinity of this definite integral. And now what I can do is I can evaluate just this independent of what t is approaching. Now, I want you to notice something here, and this is going to be something important later on. Where is x plus 3 going to be undefined? Or where does it have a vertical asymptote? At -3. Where does x plus 1, where is this part going to have a vertical asymptote? At -1. So we have vertical asymptotes at -3 and -1. Neither one of those is going to be involved here. So we don't have to worry about the type 2 discontinuity, the type 2 improper limit, or integral, sorry, because -1 and -3 are both outside of this interval. So we're not going to have to worry about that. And we're going to know that, well, we're going to have positive numbers here in the denominator, and that is going to be important later. Next thing I'm going to do is I'm going to rewrite this. I'm going to take the antiderivative. So the antiderivative of -1 over x plus 3 is negative natural log of the absolute value of x plus 3, and we have natural log of x plus 1 for the antiderivative of this. And what do we know about these absolute values here? Based on what we just said. Since we're looking at numbers going from 0 to infinity, remember t is going to approach infinity, so this is going to be a really big positive number. So since all of these numbers are positive that we're plugging in here for x, then that means that this is always going to be positive and this is always going to be positive, and so the absolute values there are not going to be necessary. So the next thing I'm going to do is I'm going to evaluate this, and there's a bunch of different ways you could approach this. Some people might write this as a single logarithm first. In fact, I probably should have done that, although I didn't. So if we wanted to write this as a single logarithm, we could do the natural log of x plus 1 over x plus 3, since we're subtracting this log. Any way that you do it, you're going to get an equivalent answer. And so when we plug in the t and the 0, what we end up with is a natural log of t plus 1 over t plus 3 minus the natural log of 1/3. And we get that just by plugging the t in for the x's here and plugging the 0 in for the x's here. And I skipped over a step there. I actually combined some of the logs. I could also combine these two by doing what? So this is going to be equivalent to the natural log of 3t plus 3 over t plus 3, and that takes care of this also. So now we can evaluate this limit, and to evaluate that limit, I'm going to rewrite this. This actually looks here like something that we might do L'Hopital's rule on. If this was just the limit as t approaches infinity of 3t plus 3 over t plus 3, and there was no natural log, we could do L'Hopital's rule. Since the natural log is there, it kind of throws a wrench in it. So what I'm going to do is I'm going to go back to what we did at the beginning of the year. I'm going to divide everything by t. So 3t divided by t gives me 3. 3 divided by t is 3 over t. T divided by t is 1, and 3 divided by t is 3 over t. So when I do that, what happens to this term here and this term here? They're going to go to 0. Since we have 3 over t, and t is approaching infinity, then 3 over infinity is going to be 0. So those are both going to go to 0. And so what do we have left? Not 3. The natural log of 3.